Example number 25. Find the x values of all points where the function has any relative extrema. Find the values of any relative extrema. Our function, f of x, is 8 plus, in parentheses, 8 plus 7x, close parentheses, to the 2/7 power. So remember, the relative extrema of a function occurs if it's changing from increasing to decreasing or decreasing to increasing. That's going to give you a local max. That will give you a local min. Increasing to decreasing, maximum. Decreasing to increasing, minimum. So we've got to find that derivative to find where that function is increasing and decreasing. So the derivative of 8 is 0, and we're going to have to apply the power rule to this second part. So it's going to be the power, 2/7, times the base, 8 plus 7x, to the power, minus 1, and then don't forget the chain rule. The derivative of the base is 7. So next, I'll simplify my exponent. 2/7 minus 7 over 7, because 7 over 7 is a 1, is a negative 5/7. Negative 5/7. And then times a 7. However, the 7 on top and the 7 in the denominator will divide to 1. And that's just going to leave us with a 2 times 8 plus 7x to the negative 5/7. And I'm going to move that base to the denominator and get an 8 plus 7x to the positive 5/7. Now, to find our critical numbers, we have to remember there are two kinds of critical numbers, where f prime of x is equal to 0 and where f prime of x does not exist as long as f of x exists at that number. So if there's something that's left out from the original function because it's undefined, you can't call that a critical number. But if it's left out of the derivative, you can call it a critical number as long as it is not left out of the original. So this fraction can never equal 0, because the only way that a fraction can equal to 0 is when the numerator equals 0. Okay? And 2 can never be 0. But this fraction does not exist if the denominator is equal to 0. So we'll say 8 plus 7x to the 5/7 equals 0. Now, technically, it can never be 0, but this is where the fraction doesn't exist because you have division by 0. So that is called a critical number. Now, to get rid of this exponent, we got to raise both sides to the 7/5. Well, 0 to any number is going to be 0. And look, when you raise a power to a power, the 5/7 and the 7/5 get multiplied, and that's 35 over 35, which is 1. So basically, by doing that, we just remove that exponent, and we're left with 8 plus 7x to the 1. So 8 plus 7x equals 0. So that gives me 7x is negative 8 divided by 7, and I get x is negative 8/7. So I'm going to put that on a number line as my only critical number. And I'm going to see if the derivative changes from positive to negative or negative to positive, so I can identify if there is an extreme value here at negative 8/7. So I have to check f prime of x to the left of negative 8/7 and to the right. And 0 is going to be an easy test point. 0 is always to the right of a negative number. And negative 8/7 is negative 1 1/7 because 7 goes into 8 one time with 1 left. So I'm just going to pick a negative 2 over here. So my test point on the left, negative 2. My test point on the right is 0. And I need to check that in my derivative. So f prime of x was 2 over 8 plus 7x to the 5/7. I'm going to put in the negative 2 first. So 8 plus 7 times negative 2, all of that to the 5/7 power is 2 over 8 minus 14 is negative 6. And this is going to be a negative number. Okay, you can put that in your calculator, but if you've got an odd root of a negative number, it's going to be a negative. And I've got a positive divided by a negative, which is a negative. Now the easier one to check, f prime of 0, this was f prime of negative 2, and now we're doing f prime of 0, is going to give me 2 over 8 plus 7 times 0 to the 5/7. That's going to be 2 over 8 to the 5/7. This is a positive divided by a positive, so this is going to be a positive. So we have a negative on the left, meaning the function is decreasing, and a positive on the right, meaning the function is increasing. So here we have a local or relative, those are interchangeable words, minimum. Now to find that minimum, we have to put it in the original function. Not in the derivative, but in the original function. And our original function, f of x, was 8 plus 7x to the 2/7. So I'm going to do 8 plus 7 times negative 8/7 to the 2/7 is going to give me 8 plus 8, and then these 7s, one on bottom, one on top, I'm going to divide out. So negative 8 to the 2/7, and that's going to be 8 plus 0 to the 2/7, which is 8. So our relative, or local, either word, relative minimum of 8 occurs at x equals negative 8/7.